Right. In class activity 9B, is my answer right? Two teams of scientists are analyzing a sound wave coming from outer space. One team finds that the function f of x is equal to 3 sine squared x plus 5 cosine squared x models the wave very closely. The other team uses the function g of x equals 3 plus 2 cosine squared x to model the same signal. 1. In preview assignment 9B, you saw that these two functions have the same graph. Part A, does this prove that the two functions are the same? Well, it doesn't prove it, so we're going to say no, it doesn't prove it, but the graphs do provide strong evidence that they could be the same, but it's not proven. Let's go to part B. Part B says, how might one prove with certainty that the two functions are the same? Well, one method might be to use algebra and trigonometry to prove that 3 sine squared x plus 5 cosine squared x actually equals 3 plus 2 cosine squared x. And until we prove it, we really don't know whether that's a true equal sign. So I'm going to put a question mark up there. So let's go to the next screen. Objectives for the activity. You will understand that one may need to use trigonometric identities to get correct answers to match those given in an answer key. You will be able to use the Pythagorean identity to rewrite trigonometric expressions in equivalent forms. One way to show that two functions are the same is to prove that 3 sine squared x plus 5 cosine squared x equals 3 plus 2 cosine squared x is an identity. Here's one way to prove this. So if we start with the left side, 3 sine squared x plus 5 cosine squared x, you see the first thing on the first step that was done, they split the 5 cosine squared x into 3 cosine squared x plus 2 cosine squared x. What that allowed us to do is factor out a common 3, and then inside here, we have sine squared plus cosine squared x, which ends up being 1. 3 times 1 is simply a 3, and we're left with this last piece here, the 2 cosine squared x. So yes, the left side here does equal the right side, and this is an identity. Let's go on to the next page. When students work homework problems from a textbook, they often check their answers by asking Bob, look in the back of the book. Suppose you work 5 problems and get the results in the left-hand column. The answers from the answer key are given in the right-hand column. Decide whether each result is correct. If a result is correct, show the step that you can use to rewrite your answer in the form given in the answer key. If the result is not correct, explain how you know. Well, let's look at, I'm just going to go to the next screen and do each of these on a separate page. So let's see, I'll just go to number screen here. And what we have is the question, this is number 2, and it's the cosine squared x minus sine squared x. And we want to know whether that's equal to 2 cosine squared x minus 1. So what we could do is start with I'll start with the left side. That's the answer that we got in this scenario for homework. Cosine squared x minus sine squared x. And that's equal to cosine squared x minus 1 minus cosine squared x. I just rewrote sine squared x in terms of 1 minus cosine squared x. And that's going to be equal to cosine squared x minus 1 plus cosine squared x. I just distributed the negative sign in front of the parentheses. And then we end up with a cosine squared x term plus another cosine squared x term. That's 2 of those terms. So it's 2 cosine squared x. And then we have the minus 1. And there's the right-hand side. So that's true. Let's go to the next problem. It's number 3. So it's 3 cosine squared x times sine x minus sine cube x. And we want to see if that's equal to 3 sine x minus 4 sine cube of x. All right, so I'm going to start with the left side again. 3 cosine squared x sine x minus sine cube x is equal to, well, I noticed that both of these terms have a sine x common. So I'm going to factor that sine x out. And then inside the parentheses, we'll have a 3 cosine squared x minus sine squared x. And then equals, I'm going to just work with inside the parentheses for right now. So I'll write the sine x in front of the parentheses. And then let's write this as 3 is going to be a 3. And then instead of writing cosine squared x, I'm going to try writing 1 minus sine squared x. And then we still have a minus, and then a sine squared x, close the parenthesis. Then we have equals. Sine x on the outside still is not changed, so I'll just write it down. And then we have what, a 3 times 1 is 3, and then a 3 times sine squared x, it's negative, so it's minus 3 sine squared x. And then we still have this minus squared x term. Close the parenthesis. Equals sine x, parenthesis, 3, and then minus. Notice we have a 3 sine squared x term here, and then another minus squared x term here. That's 4 of those terms altogether. So we have a 4 sine squared x, close the parenthesis, and then we're left with, if I distribute the sine x to both terms in the parentheses, we get a 3 sine x minus 4 sine cube x. And there we go. So that's a true statement as well. Let's go to question, that was 3. Let's go to question 4. And this is a cosine of x over sine of x plus sine x over cosine x. Okay. And this is supposedly or maybe equal to 1 over sine x times cosine x. So I'm going to start with the left-hand side again and just write that as cosine x times sine x plus sine x over cosine x. And I notice my denominator on the right side has both a sine and a cosine term in there. So the way that we can force that to happen is I can multiply by cosine x over cosine x here, and we can multiply by sine x and sine x right there. So when we do that, we get cosine squared x over sine x cosine x plus sine squared x over, I'm going to write it as sine x cosine x. And then we have 2 fractions with the same denominator, so we can write this as a single fraction over that common denominator, sine x times the cosine of x. And then I'm going to switch the terms here. I'm going to write sine squared first, so sine squared x plus cosine squared x first. And we know that sine squared x plus cosine squared x is 1. And then the denominator is still sine of x times cosine of x. And that's what we have on the right side of the equation that we started with. So again, that's a true statement. Number 4 is true. Let's go to 5. So 5 says 3 sine to the 4th of x plus 3 cosine to the 4th of x is equal to 3. Now, this is not going to be true. And to see that, you can try to graph it. So I want you to graph this to see that these are not the same. Number 6, last question. We get this here. We're given this, the sine the fourth of x minus cosine, that's the fourth, x is equal to sine squared x minus cosine squared x. So start with the left side, sine to the fourth of x minus cosine to the fourth of x. And what I'm going to do, I want to try to factor this. So when we factor this, we're going to get sine squared x plus cosine squared x, and then times sine squared x minus cosine squared x. Sine squared x plus cosine squared x is just 1 times sine squared x minus cosine squared x. Well, I don't have to write the 1 anymore. We can get rid of the parentheses, and we have sine squared x minus cosine squared x, and that's exactly what we had on the other side of the equal sign when we started, so that is true as well. And thank you. That's the end of this video.